Duplicate prompt names can silently overwrite your carefully crafted templates if you're not careful. We'll configure FastMCP to explicitly prevent accidental prompt collisions by raising errors when duplicate names are detected, ensuring your prompt registry stays clean and intentional. You'll see how the On Duplicate Prompts setting gives you full control over whether duplicates are ignored, replaced, or flagged as errors. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals prompt server. On duplicate prompts equals error. Hash raise an error if a prompt name is duplicated. At MCP, prompt. Def greeting. Return hello, how can I help you today? Hash this registration attempt will raise a value error because hash greeting is already registered and the behavior is error. Hash at MCP, prompt. Hash def greeting. Return hi there, what can I do for you? This demonstrates the registry pattern combined with declarative configuration for managing reusable prompt templates. The core concept is treating prompts as first-class components that are registered, validated, and versioned through a central system, rather than ad hoc string templates scattered through code. What makes this distinctive is the dual nature of prompts as both executable Python functions and discoverable assets in the MCP protocol. The system works by using decorators as registration hooks that capture both the implementation and metadata in one declaration. When you decorate a function with @MCP prompt, FastMCP automatically extracts the function signature for parameter validation, the docstring for documentation, and the return type for response formatting, while maintaining a clean separation between template logic and registration. This declarative approach means your prompt definitions stay close to where they're used, but remain globally accessible and consistently managed. The real-world benefit is eliminating the template sprawl problem common in LLM applications, where similar prompts get re-implemented with slight variations. By centralizing prompt management, you gain automatic validation, versioning through metadata, and runtime discoverability for clients. The trade-off is some initial framework coupling, but the payoff comes when maintaining systems with dozens of prompts across multiple teams, or when needing to audit or update prompt behavior at scale. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI callable tools. It bridges Python functions to AI models, handling registration, validation, and execution. MCP equals FastMCP. This instantiates the core FastMCP server, the central registry for all AI callable tools. It handles prompt registration, validation, and execution routing between Python functions and AI models. Name equals prompt server. This names the FastMCP instance, prompt server, creating a distinct namespace for all registered prompts. Prevents collisions when multiple FastMCP instances run in the same process, ensuring each prompt set stays isolated. On duplicate prompts equals error. Hash raise an error if a prompt name is duplicated. This configures duplicate prompt handling to raise an error. It prevents accidental overwrites when registering multiple prompts with the same name, enforcing explicit naming discipline in your toolset. This closing parenthesis finalizes the FastMCP instance initialization. It locks in the configuration, including the duplicate prompt handling behavior we just set to error. At MCP, prompt. Def greeting. Return hello, how can I help you today? This registers the greeting function as an AI callable prompt. The @MCP prompt decorator exposes it to the FastMCP server, making it available for AI models to invoke by name. The server enforces uniqueness, preventing duplicate prompt registrations when configured with onDuplicate prompts equals error.
Hash this registration attempt will raise a value error because hash greeting is already registered and the behavior is error. Hash at MCP, prompt. Hash def greeting, return hi there, what can I do for you?
This commented out code demonstrates FastMCP's duplicate prompt protection. When onDuplicate prompts equals error is set, attempting to register a second prompt with the same name raises a value error, enforcing unique prompt identifiers. This prevents accidental overrides that could break existing AI workflows. Duplicate prompt handling. FastMCP 2.1 Plus gives you explicit control over prompt registration conflicts, moving beyond silent replacements to intentional behavior patterns. The default warn behavior logs conflicts, but still replaces prompts, which can create subtle bugs if you're not monitoring logs. Always set onDuplicate prompts equals error during development to catch accidental overwrites early.
The prompt that refuses to be replaced becomes the foundation of every conversation.